I guess we're ready to start. Welcome to my talk now, which is called React Hooks Broke My Tests, Now What? So to introduce myself, I'm Daniel Afonso. I'm the person on this photo, which is on the left. The person on the right is my pair programming buddy here. I'm a developer advocate here at OLX Group. I'm an OT ambassador, a GetIO instructor, and you can find me on Twitter pretty much anywhere at the handle Daniel GC Afonso. So what is this talk about? What am I going to be talking to you in the next couple of minutes? Well, this talk is about a migration to React hooks that showed us that our tests were not written the way we expected them to be. During this process, we had to go through a migration by changing from Enzyme to the React testing library. And it's exactly for the React testing library that the later part of this talk will focus. I will hopefully give you a guide for everything that you need to start using the React testing library, as well as some common issues that I've personally done, I've seen coworkers do, and how we overcame them and fixed them. So get strapped because we're going to start. So let's start with some context. We were in mid-2019, so it was a long time ago at this point right now, looking at it. And we have had a fairly new React Redux project. At this time, hooks have been around for like 3-4 months ago, so they were still very, very recent. It was not what they are right now. And yeah, we decided, okay, let's start using React hooks in a project, considering we have the technical freedom to do it, and we are able to justify their worth. What do I mean by this? Because hooks came around with a couple of new things, with more code readability, code reusability, and ease of teaching. So focusing on code readability first, one of the things that we had before hooks with class components and everything was that we ended up writing grouped and related logic inside of our component did mount, component will mount, etc. So basically our lifecycle functions, which what we had before, were being like a huge amount of code that would get grouped together, and it was code that was not related. And this affected the readability of our components. It was not easy to understand what was happening there. With hooks and with introduction of use effect, we could write as many effects as we wanted for their single responsibilities. And well, we had no longer had to worry about related logic being non-related logic being together. Then we had code reusability, because before hooks, there was no way to statefully share state in React. Well, I'm lying, we had mixins for a while, but then they were deemed unsafe. And then we had patterns like high order components, but this came at the cost of reordering our code and reorganizing everything and adding extra layers, which was not great. With hooks and with the ability to have your own custom hooks, now this stateful way existed, and it was so much easier to use. And finally, one of the great things that hooks gave us was the ease of teaching React, because before hooks, well, let me tell you, it was terrible to teach React to a newcomer because it had all the technical layers and the technical background that you need to have to understand a bunch of stuff in JavaScript, like classes, these event bindings. It was a bunch of stuff that, okay, it will eventually be part of your growing process to learn them, but it's easier to teach something in React if they don't have to worry about it. And with hooks, it was easier to learn React. And we at the time knew we would be hiring some new developers, and this made it easier for us to teach them how to use React. And yeah, this was pretty much a bit of our justification to use hooks right now. Well, we don't need to justify it anymore. It's a new standard. But yeah, we started migrating our code base to React hooks. And this is us furiously typing and migrating everything. Well, at the end of the migration, everything seemed successful. Our code was, well, almost half of the lines of the code we had previously. Everything was much more readable, easier to understand. And it even seemed our application was running faster until someone remembered, hey, have you run the tests? And so we did. And this is what happened. Almost half of our tests were failing. Yeah, so you could probably imagine that this was our reaction at the time. We were, well, left to wonder what happened, what's happening here, why did our test break? Everything is working as it did previously. There's exactly the same behavior in the browser, we only changed the implementation. Well, and that was the problem. The problem was because we were testing implementation details. Now you might be wondering, what are implementation details? As Kensidot says, implementation details are the things which the users of your code will not typically use, see, or even know about. And putting this in perspective, our tests were full of implementation details. We were tying our tests to a bunch of stuff that our user didn't had to know it existed to run our application. And yeah, and from this point on, we were very, very sure that the tool that we were using at the time, which was Enzyme, didn't fit our use case. So we decided to migrate out of it. Now, don't get me wrong, Enzyme is great, but it had a couple of things that personally I don't like, and here are a couple of them, starting with shallow rendering. So shallow rendering is a way where when you're rendering your components, you're only rendering the shallow part of it. What I mean by this is if you're rendering a component that has children, the children won't be rendered. It will only render the part of the component that's shallow, doesn't have the children. And once again, this might be an argument being traded to testing this in isolation, but the mentality and the mindset we wanted to fit and the new mindset that we thought and we would understand that the front-end community was moving into is that we have to focus on the way that the user does stuff. And shallow rendering our components is not the way that the user will see our component. Our component, when a user sees our components, it's interacting with the parent and with the children. So shallow rendering was not working. Another thing that was not working for us was the find method. Find is super, super powerful, but the thing is, if it's not used properly, it will give you some access to implementation details, like for instances, the component name. And once again, when a user is interacting with your page, it doesn't care about the component name. It doesn't care if there's a component called foo. What he cares is, I want to find a button that does this. And once again, find was great, but it's incentivized to have patterns that we didn't like. And the next thing, and probably the biggest implementation detail in our tests, we're tying our tests to the component state. Once again, the user doesn't care what the state of your component is. What the user cares is, if I click a button, will this data appear, or will something indicate me a response to my action or something like that? Or the user doesn't care if the state is true, if it's false, it's A or B. The user cares if something shows when it does an action. And yeah, by tying our tests into these things, we were tying our tests into a bunch of our implementation details. And this was not the way that the testing library showed up into our world to change this mindset. And with the mindset of testing library, here's the quote by its creator, which is Kensidot: the more your tests resemble the way your software is used, the more confidence they can give you. So now during this next couple of minutes, I'll be introducing the React testing library and showing you pretty much all the tools that you need to write a test with it. So starting at the beginning, here we have an example of a test where we are doing a couple of things. We're starting by importing the things we need to render our test and to fire some events. We describe our test use case, and then we do a couple of things. We render our component, which is going to be rendered into a DOM. We'll see a bit more. And then we destructure from it a query. By using this query, we'll be able to search on the DOM for something. In this scenario, we are searching for something that has the label text label. Once we get the input or whatever that's associated with this label, we can use our fire event to fire a change event into this input by changing its value to be some value. And then we do our assertion. And this is pretty much an overview of the test. Now we're going to get even more specific and diving into each one of these things. So starting with a render. What a render does is a function that will render your component into a container, which will be afterwards appended to the document body. Besides doing this function also gives you a couple of utils, like the container where the components it's rendered, a debug function, so it can you can check the current way your component looks on the DOM. an unmount function if you want to trigger an unmount event, and a re-render function if you want to trigger a re-render of the component. So this is the rendering part. Now, next comes or not the trickiest, but one of the main focuses of the testing library, which are the queries. There are three variants of queries: the query by, the get by, and the find by. It's important to know that the main objective of the queries is to find for stuff on the DOM, but these three variants that I mentioned have different behaviors. What I mean by this is when you're using a query by variant, it will find the first matching node or return null if it doesn't find it. So if you query for something, if it exists, it returns it. If it doesn't exist, okay, it returns null. Then you have a second variant, which is the get by, which, like the query by variant, will return the first matching node, but if it doesn't find what it's looking for, it will throw an error. Both of these variants are synchronous, so you don't need to wait for them. They are synchronous. If for some reason, imagine that you have a button that you click and then you want to wait for something to appear on the DOM. This is a process that it still hasn't happened. It will appear. You know that that component will be on the DOM. So here you need to use the find by variant, which is asynchronous. Pretty much this variant is a variant of query that will return a promise that will resolve when it finds the matching node or reject if there are no matches. So recapping, query by and get by, both synchronous, both will find the first matching node. The query by will return null and the get by will throw an error. The find by, it's asynchronous, and when it resolves, it will either return the node you're looking for or reject. Both of these three examples only use return the first matching node. If for some reason you're thinking, okay, but if I want to get all the nodes that match, then you can support adding a null by variant. So what I mean by this is you can do query all by, get all by, find all by to get an array of all matching nodes instead of only the first matching node. So this is the principles of queries, but all queries belong to a family. And there are four families in there are actually three. The fourth one is not more of a family, but there are three families to the queries in the React testing library. They are the queries that are accessible to everyone, the semantic queries, and the test IDs. And then we have the manual queries, but we'll see in the end what they are. So when deciding an order to picking a query in the React testing library, you should always start from the queries that promote accessibility. You should always start from the first part and then going down all these ladders. So what I mean by this is, what query do I need to use? Okay, let's start by queries that are accessible to everyone. If these don't work, okay, then let's go to semantic queries. If semantic queries don't work, then okay, let's go to test IDs. And all these queries are of a specific family because these families are the families that define accessibility per se. So how would this work? You would pick the variant, query by, get by, find by, and then append it the family. So if you want to find something by text, you would do get by text, get by role. If you want to find by aria role. If you want to find by placeholder text, get by placeholder text. And these are the queries that belong to the queries accessible to everyone. And these are the queries that mostly reflect the experience of visual, mouse, and assistive technology users. So these are the ones that you should always have in the top of your list when writing tests and when writing queries. If for some reason this doesn't work, then you can use semantic queries, which are queries that make use of HTML5 and ARIA compliance selectors. And these are the by alt text and the by title. Why you shouldn't pick these ones first is that because they don't fully reflect the experience of visual, mouse, or assistive technology users. I'll give you an example, not in the next slide, but in the slide after that one. So how would this work? Let's look into an example of using a query accessible to everyone, which is the label text one. So imagine that we have this label here, and this label it says username and it has an ID. And then we have an input that has the area labeled by and username label. This means that this label will be assigned to this input. So how do we go into querying the DOM to getting this input? So first thing we do is we render our component, and from our render, we destructure the query that we need. In this scenario, we have a get by variant, which will return the first matching node or throw an error if it doesn't find it. And then we append it the label text variant. And then, yeah, we query the DOM and we say, okay, give me the label text username. And what this query will do inside of it is it will look into our DOM. It will look into our label that has the text username, and it will ask it, is this label assigned to anything? Yes, it's assigned to this input thanks to the area labeled by. And then it will return this input that will be assigned to our variable. And yeah, this is pretty much the process of querying with the testing library. And here is an example of a query that's accessible to everyone. Here's another example where we are using the title attribute. And this is a semantic query. Like I said, semantic queries should be our second choice because, for instance, in this scenario, the title attribute, by default, it's not shown on screen readers. So it doesn't show by default, not showing by default on screen readers. It doesn't give you the full experience of a user that has some assistive needs. This is why this should be your second choice. But the process for querying from your side, it's pretty much the same thing. You render a component, you destructure the query, and then you query the DOM. In this scenario, I query the DOM by the title delete. It will look into the DOM. Okay, we have a title delete, then it will return it. And yeah, these are the two types of families that you should always start with, because once again, user experience don't reflect implementation details. Now, if for some reason none of these work, then you can introduce an implementation detail, which is the test ID. Why is it recommended for you to use the test ID? Because it's a controllable implementation detail. So imagine, for instance, that you have a div which the content inside is always rendering or always changing, and you cannot control what it's going to be there at certain times. So probably the only way for you to work on the DOM for this div, it's by assigning a test ID attribute to it. And by doing this, you can have at least a simple control of an implementation detail that, well, you don't want to change. And probably when you want to use test ID attribute queries, it's as a last resort, but there's an even greater last resort, or even worse last resort. What I mean by this is there is even manual queries. So manual queries are not an actual query of the React testing library, but they are a query selector API that belongs to the DOM. If you should only use test IDs as in like 5 or 7% of the cases, for manual queries, you probably only need them like in 0.001%. I only had one use case in 5 years of testing of using the testing library. 4. Okay, in these 4 years of using the React testing library, or 3, that needed to use a manual query. But looking at examples, here we have a div. If this div, there's no other way for us to query the DOM for it, then we assign a test ID. And then on the process, it's the same. We render a component, we do our query, and we destructure a query, and then we query the DOM for it. For the manual queries, like I said, they are not an actual query from the testing library. So the way for you to query the DOM for stuff, it's not the same. What you have to do here is, instead of destructuring the query, you have to get the container where your component is rendered, and then query the DOM by using the query selector with the selector that you want to query it for it. Once again, use this as a last resort. If for some reason, I'm not going to go read all this code, don't worry, this is just here to illustrate stuff. If for some reason you want to create your own query, then React Testing Library offers you a helper, which is called BuildQuiz, and it allows you to create your own queries. What's important, once again, here is if you do this, you create your queries in a way that promotes and mostly reflects the user experience when interacting with the DOM or when interacting with your page. So, you know how to render, you know how to query. Let's go into firing events. So there are 2 ways to fire events in the testing library ecosystem. First things first, you have the fire event. Fire event, you can use it when you want to fire a single event. So the syntax is fire event dot the event you want to fire, being a click, a change, or whatever. And then inside of that function, you pass it the node where you want to fire events. So here we are firing a click event inside of a button, because we are using the get by role, and it will look for a button that has the text save on it. So here we'll fire a click on the save button. Now, this is a good way to fire events, but it's not how a user interacts with them. Why? Because when a user goes to click into a button, what happens is it doesn't fire a single event. So imagine your process of clicking a button. You move your mouse over the button, you click the button, you click in, click out, and you move your mouse out or whatever. So there are the on mouse over, on mouse click, the click, on mouse out. So there are all these events that are fired whenever you're interacting with a button in this scenario. So to deal with this, we have a companion lib from the React Async library, which is the user event library. And this library will fire all the events responsible and associated typically with that action itself. So whenever you're clicking, it will fire all the events associated with clicking. The syntax is pretty much the same. The only thing is that since version 14 of the user event library, all the functions now are asynchronous. So if you are seeing the wait here, and on your code you're not using it, don't worry. Probably you are in a previous version. But the syntax is await, user event, and then click. And once again, it's the same. You pass the node where you want to click. And yeah, that was firing. And right now you have pretty much all the things you need for your tests. Let's just go into those last two slides, which is asynchronous utilities and utility itself. So sometimes you have to wait for something to happen so you can do your assertion. For instance, you want to wait for your API to have been called for some reason so that you can assert that something appears on the DOM. So, or you want to wait for a progress bar to disappear so that you can check if your data exists, something like that. So there are two ways to do this. You can use the wait for function, which is an asynchronous function that you pass an assertion, and the assertion inside of it will be looped until it evaluates to true or until it times out. So basically what will happen here is you will wait until this expect mocked API to have been called with foo to be evaluated to true. If for some reason you want to wait for an element to be removed, you also have an util for that. So you pass it your element. In this scenario, it's something that has a label text loading. And when it disappears, then your test will proceed. Finally, some helpers. The within, the screen, and the debug. The within allows you to run a query inside of a specific node. So imagine that you have queried, you know that you have a progress bar or an input that's only inside of a div, but you have exactly the same input all around your code, whatever. You can use the within to say, okay, within my input node, I want to run this query. And this is super useful in some scenarios. Another thing that has become very useful, it's the screen object. So the screen allows you to, well, the screen as a reference to the document body where your container is. So the screen allows you to run all the queries without having the need to destructure them from the render. It's pretty much convenience, but well, it depends on preferences. Some people prefer to destructure, some people prefer to use screen. It's up to you. And the debug allows you to see the current way that your component is. So you can destructure the debug from the render. You can pass a node to see how that node looks, or if you don't pass anything, it will show the current document body. It will show everything, basically. So sorry for this nonsense or all these bunch of tips and bunch of monologue type of thing, I guess. But yeah, I've been using the testing library myself since 2019. It has been a long time. I love it. I've spoke to a bunch of people about it. I've been using it in a bunch of codes. I'm in a bunch of code bases. I'm super satisfied with it. It made my experience with testing something very enjoyable, which was something that I didn't have before. But yeah, with it also came some errors and some mistakes and some, well, issues. And there are a couple of them. So I'm not going to read them all of them because I'm going to show you now. So the first error and the issue that I did, and I've seen quite a lot of people doing this one, is using ACT. So what is ACT? Well, when you're doing actions that are called units of interaction with the user interface, sometimes, mostly, you need to wait until these units of interaction happen. So imagine, what are things that are called units of interaction? Firing an event, doing some data fetching. These are all things that are called units of interaction with the user interface. ACT, it's an util that the React team created to make sure that all these units of interaction with the user interface are finished before your test proceeds. So this makes sure, okay, I click the button. Is this quick finished? Is all this process finished? Yes. Okay, so your test can proceed. So with that being said, it might make sense to use ACT like this. So we are rendering a component. Let's wrap ACT with it because, or render with ACT because it's a unit of interaction with the user interface. We are firing an event. Let's wrap it with ACT. The thing is, almost never need to use ACT with the React testing library. Why? Because all the things and all the functions that are going to be doing something that's going to be triggering a unit of interaction with the user interface already have ACT wrapped inside. So if you see an ACT in your code, then there's probably something you've forgotten to deal with. I know there's an error that happens sometimes. We'll see it a bit further. So if you're thinking about that, don't worry, we'll address it. But you almost never need to use ACT because React Testing Library already wraps everything with it for you. Using a get by with the expect not to be in a document. So expect not to be in a document, it's an assertion. In this scenario, to be in the document, it belongs to JSDOM. And this is an assertion that, well, it's going to validate if that node you're passing it exists or not into the document. So this pattern that I've seen a couple of times already is using a get by variant to query for something that we know that it's not going to exist. As you remember, get by, it's going to throw an error if it doesn't exist. So your test will fail and immediately before getting into the assertion. So instead, what we need to do is swap our query to use a query by variant. Yeah, this is how you fix this issue. Next one, using await with fire event or non-asynchronous queries. So I've seen some people doing this. The thing is, you don't need to. What are we doing here? We are waiting for our get by role, and we are waiting for our fire event to be clicked. We don't need to do this because these are not asynchronous functions. If you using the only reason that you're going to be using an await is if you're waiting for an asynchronous util, if you're waiting for an asynchronous query like the find by, or if you're using the user event library. With all these things, you don't need to await for them. Using await for with an empty callback inside of this. So here we have a pattern where we fire a change event, then we wait for nothing, and we expect this to our assertion to evaluate to true. This is a pattern that I've seen a couple of people doing to deal with an issue that I'll show you. But the thing is, the purpose of wait for, it's for you to await until your assertion validates or evaluates to true. So what actually we want to do here is we want to await for this assertion to pass. So instead of just passing an empty callback, let's pass the expect inside of it, and this will be looped until the assertion evaluates. Using cleanup. So cleanup is an util that allows you to clean up your DOM. And well, as a good practice with tests, you don't want your tests leaking into one another. So it might make sense to clean up after running each test. The thing is, if you're using a framework that supports the after each global like Jest or Jasmine, you don't need to do this because it will automatically run for you. So thank you, React Testing Library, for doing something for us and saving us a bunch of time. We're in the last two examples, I believe, but in this scenario, using wait for with a synchronous query. So what I mean by here and what we are doing here is we are using the wait for synchronous util to wait for the return of a get by query. Well, why are we doing this when we have defined by variant? So if you ever want to wait for something to exist on the DOM, then use the variant query for it. And finally, if I'm not wrong, using side effects inside of wait for. So in this example, what we are doing is we are waiting for a user event to click on the button here, and then our assertion to be called with form data. The thing here is this code will be looped. So what will happen is every time this code is looped, you will click on the button. And this might have some unexpected behavior on your tests because you're performing side effects you were not expecting it. So instead, what you should do is remove your user event click in this scenario outside of the wait for. And yeah, it is something that will probably save you a bunch of time and catch some of these mistakes that I've spoken about, which is the plugin for ESLint for the React testing library. And finally, the main and probably the most asked question and the most found issue with the React testing library, which is there was not wrapped in act error. So this is an error that appears out of nowhere, and it says, warning, an update to an app inside of a test was not wrapped in act. When testing, code that causes state updates should be wrapped in act. So like I said, and I said in the beginning of the mistakes, you should never need to use act. So why is this error telling me that I need to use act? Well, before we get into there, let's look into an example. Here we have a function called display Pokemon. This function will receive an asynchronous function called get Pokemon data, which will be responsible for receiving a Pokemon name and fetching it. Then we have a use state hook that's initialized as false and as is loading and the setter for the hook. And then we create a function called get selected Pokemon. What this function will do is receive a Pokemon name, set our loader as true, and then try to get our Pokemon data by calling our get Pokemon data function. We then set, once we have the data, set or is loading as false, or if there's an error, we set our loader as false. Okay, in our render part, we have a couple of divs, and here we have a button. When on clicked, it will call the get selected Pokemon with Pikachu, and then we have a span to display if it's loading or not. So how would we test this? Well, is a test that we all could have written. It's called should call get Pokemon with Pikachu. It's an asynchronous test, and we start by creating a mocked function by calling the justfn, and then we render or display Pokemon component, and we pass it our mock function. What we do then is we try to find a button that has the name Pikachu in it, and once we have that button, we click it. Okay, so we render a component, we click the button, and then we assert that our function, or get our mocked function, was called with Pikachu. Okay, this might be a normal test. We are asserting, we are arranging our test, we are acting, and we are asserting. We're following the AAA pattern. Now, what will happen if we run our test? This test. Warning, an update to display Pokemon inside the test was not wrapped in act. So, what is happening here? Well, the thing is, and most times when we see an error in console, it's our human nature to panic and start Googling and shouting, and what's happening? I cannot figure this out. But let's recap what we know about ACT. ACT, it's there to make sure that all the updates to the UI have been finished before you proceed in your test. So, and if you look at the error, it exactly says that code that causes React state updates should be wrapped in ACT. So this warning is there to tell us, hey, look, pay attention. There's something in your test that is running and that is happening that you are not thinking about. You are forgetting to do something. And what are we forgetting to do? We forgot our loader. So we are clicking, if we look back into our test, we are clicking our button, we are asserting that the function was called. But what we forgot is, while this is running, our loader is also being set into false. in the background. So we are completely forgetting that this is happening. So what we should do here is add this thing, is add a point and the code line, I forgot the word, to contemplate this. So what we should do here, or how we could do this, is either by two ways. By awaiting for our loading to disappear, or for waiting for it to disappear. But there are two ways we could do this. We either wait for the assertion, or we wait for the element to be removed. And this way, the error disappears, and yeah, your test is even more complete, and you're testing all the scenarios from your tests. So thank you, React, for letting us know that we are forgetting to test something. And yeah, as you can see, we just fixed them, and you just got the overview to fix the most searched error with a React testing library in 3 or 4 minutes. So congratulations. Yeah, and with that said, I finished my talk. Thank you so much for attending. This is a QR code if you want to find my Twitter account. I'm also on LinkedIn, pretty much anywhere with the handle Daniel GC Afonso. Yeah, I'm Daniel Afonso. Thank you so much. And if you have any questions, feel free to shout them now or write on the chat as well.